All right, so let's dive deep. The conventional topo grading design process is that you draw contours and you figure out all the contours, and then you build a 3D model. And if you have to change the 3D, if you have to change the design, that means that you have to redraw the contours and figure all of that out, and then go through the process of building a 3D model. The process overall is this. You start by printing out some existing contours that you have, and this is being generous because usually you have to kind of do stuff to get those contours ready. And then you do hand-drawn contours on top of that with some trace, an eraser, a calculator, a ruler. You have to scan those in. Once you have it all figured out, hard line those in CAD, trim or split them, so like where it's proposed versus existing, rejoin them perhaps, elevate them, divide them into points. If you're doing sort of a tin in Grasshopper or Rhino, and then make your mesh out of those points. And oftentimes what you get is not great because you're working from contours, trying to make a three-dimensional thing, and contours don't always understand what the human eye or mind understands, which is that there are ridges and valleys and things like that. And then once you get all of that, once you have your mesh, you're then trimming these into separate areas using SketchUp or Rhino or whatever program, and trimming meshes and splitting meshes is a nightmare. And you're putting those on different layers. That's a traditional usual workflow that we're probably a little familiar with. So then we're going to, with Topo Kit, the alternate process is that we start by elevating contours because we're working in 3D. We draw in plan. So there I say we're working in 3D, but we're kind of, our design process is constantly in 3D, but there are things that we do that are 2D that are kind of inputs for the 3D workflow. So one of those is drawing a proposed boundary, right? Or drawing something that is not at 2D. In 2D is drawing break lines or putting in spots, or even maybe, dare I say it, contours. But you can bring all those different things in together. You can also bring in features. So you can draw things in three-dimensional space like walls and curbs and curb cuts. You can bring in stairs and paths, and all of that stuff will act as kind of its own sort of break line or set of break lines to manipulate the changing of the topography. And then we also have our topo mods. So part of the way you can actually change something is using the patch mod, which is just using some of the other methods, but you just do it within a new boundary within your existing terrain or topo. And then the other mods we're going to show you a little bit more about: grade, sculpt, and smooth, and I'll talk a little bit more about those. From there, you have a mesh. It gives you a mesh, and then it's cutting contours. You can cut contours live while you're working and manipulating these features, and you can actually turn on topo analysis as well to see what the slope is. So we think of this as a 3D design process where you're actually designing something in 3D, right? You're not designing it on paper, trying to work through it all. And we're a big fan of drawing, and we know that so many people are, and we still think drawing is a great way to get up to a certain point. But we think you can move into 3D faster and skip over the CAD part, and then come back to CAD whenever you're really doing heavy documentation. So designing in 3D, having simpler geometry inputs, having a mesh or contours or feature models like walls and things as outputs that you can use, and then adjusting and seeing how those things change, and having that just be a constant feedback loop in your design process. So what this sort of looks like in Grasshopper, basically, is that we have two main inputs for the topo. We have a geo set, which has the basic geometries, break lines, contours, spots, things like that, and maybe contours. And then we have feature geometry coming in. So, or things that make geometry, that make features. And then those features get fed into the topo. So like you can actually input walls and curbs and paths to manipulate the topography. Once you have a topo, this looks like, okay, why do I have so many steps to create it and draw it? Well, you'll see in a second, it's because we're going to be modifying it somewhere in between. But in this simple workflow, you create and then you draw, and you can draw at different varying levels of resolution if you want. From there, you get a topo mesh that you can analyze using the slope analysis or other kinds of analysis. And then you can get contours as an output of the process rather than an input of the process, which is sort of crazy. So a kind of a more advanced workflow might be all of the same stuff, creating a geo set and a set of features that create topo, but then you can also take a new geo set of like a proposed condition or a revision condition, or revised features, and input those to actually patch or modify the topography. We also have mods for the features as well. Specifically right now for curbs, you can create curb cuts, and we'll show you how to do that. So after all that, you draw it and you get mesh and contours, and maybe another kind of advanced thing you might do is cut and fill. So using an existing mesh and a proposed mesh, and then comparing the two of those and seeing how they vary and getting a numeric understanding of the volumes that you're dealing with. So the mods I mentioned, are there any questions so far? Hopefully pretty clear. The mods I mentioned are actually really new. The grade topo mod and the sculpt topo mod are new additions in the most recent version 1.0.5 of Topo Kit. The grade topo mod allows you to take an existing grade, the original topo, and place geometry at some elevation. It could be floating above, it could be below, and it could be a path, it could be a point, it could be a platform, or a center line for a swale, all kinds of things. And what it will do is it will grade away from that geometry down to or up to your original topo. You can add an offset so that, like, let's say you use a center line for a path, and then you could actually offset to the sides of that path a certain amount. Or if you have a piece of geometry and you're like, I want to offset this a little bit, I want to give it a little bit more of a buffer, you can do that as well. And then the sculpt topo works in a very similar way, but it actually, rather than being based on geometries that are in 3D, it's based on geometries that are flat on the ground. And they simply offset, that there's an offset and a distance, a spread distance, and a height. And so what it will do is it will lift the topography to by the amount of the height that you've said at the location of that geometry. And it's hard to understand until you actually see it, and Ben's going to show it. But in a way, it kind of it's allows you to push and pull the existing topography as it is, rather than having to define something in 3D space first and then grade away from that. And there's each of these tools, the grade and sculpt, have different applications, and we'll get into that. So just last thing very quickly, we're going to be talking about this idea of the collage and about areas. The typical conventional process is that you have a mesh and you try to trim that, as I mentioned, and that can be a total mess. And we just made the word big because it's a big mess. And then you have to sort those things out and put them all the layers. But anytime you change your topography or your areas, you're doing the same thing, right? You're retrimming or resplitting, and it just becomes a mess. So without it, you're splitting, you're assigning layers. You have to create a hatch from scratch after the fact. You have to calculate totals of areas kind of on your own. And to make changes, you basically have to start over. With Topo Kit, we have this whole areas system that allows you to have your area sort of line work, your boundary work, which is typically how people work in CAD. They just say, okay, one line is going to define the boundary between two things. You can then take a big surface and split that up using all that line work, put those surfaces on different layers, And that becomes a much more flexible system than having things split as hatches or in 3D as a split mesh, because what we can do is actually project those areas, and manipulating those surfaces is a lot easier than manipulating a bunch of boundary objects or manipulating hatches or whatever. It's actually actually a really great way of laying out your site that we've kind of stumbled on in the process of trying to make all of this work together. And it's just all about tweaking and changing as you need to, and it makes it easier to do that. And our collage tool allows you to have surfaces that aren't necessarily trimmed the way you need them to be. As long as it looks the way you want it in plan, it will smash everything together and make that into like a plan. It's pretty neat, and you'll have to just see it in action to really kind of get it. But it's a 3D design process where you're manipulating these inputs and you see an output, and then you can just manipulate those inputs some more and see the output, and it's a feedback loop. So I'm going to let Ben hop on to the example.
So we're just going to talk a little bit about inputs. This is just sort of covering the basis of things that we have found that are good things to check, good things to remember when you're starting with a Topo Kit file or LandKit file in general, is especially with like real life examples when you're dealing with surveys coming in and they have contours and line work and all this stuff. How do you parse through this to create your workflow and start working in Topo Kit? So we have this example of a project that we worked on to show, and we just have an example of a pretty standard survey that we received from a client. And in plan view, you can see some of the line work of where they've defined the road and gravel, and curves and things like that, and paths. And then lucky for us, all of our contours were already elevated to the appropriate elevation. If that's not the case in your file, that is something that you do have to still do manually, unfortunately. It's happened to us. But this is also a pretty convenient file because they've actually color-coded and separated out the proposed contours versus the existing contours. So when we receive a file like this, oftentimes what we'll do is we'll bring it in as a block into Rhino. And the reason for that is we can keep all the survey information packaged in this one little space. And then we can go inside of the block by double-clicking on the block and entering it, and then copying the necessary information out and sorting it into the appropriate layers that we'll be using for our Topo Kit file. So I'll lock this because if you go in and inside and outside of blocks, it will reprocess your Grasshopper script. It can be quite irritating sometimes, but if you just jump into a block and you can grab all these contours and just copy them out, and you end up in the space outside. And then with those contours, you can copy them into your different layers or apply them into your Grasshopper script to start using those contours for your Topo Kit file. A few things to remember about just in general, like dealing with geometry from Rhino into Grasshopper, but also it applies very much to Topo Kit as well, is making sure you don't have, we've only run into this a few times, but making sure you don't have duplicate line work. Sometimes surveys come in really messy and you end up with contours that are doubled up. Do you have a comment, Chris?
Yeah, the easy way to find duplicates is to type SCL dupe, like select duplicates. And I don't know if that's the full command. Yeah, SCL dupe. And it will look for duplicate geometries. And Ben probably is not seeing anything because he's outside of the block now. But if he was, oh, no, you are in the block. Okay.
Oh, no, I just copied some.
Oh,
so we'll see if there's any in there.
Yeah.
Oh, yeah.
And then once you have that, you just say delete. And it only selects one, or, it always leaves one if you say select duplicates, and then you just delete the ones you don't want. It's kind of like overkill in CAD, I think is the command that is used. The other thing to note is if you want to select all of the red contours, for example, if you just click on one of them and you down at the bottom, you can see that the layer name, and it says CAD and then it's a double colon. That means it's a parent layer of something. So CAD, double colon E surf, and then you can go to that layer and right click on it and say, select all geometry or select objects, and it will select everything on that layer. That it's just a way to kind of get all that information, and then you can copy that out and sort of copy that onto your contours layer.
Copy that in. And then since this would be existing, you can go to existing, right click and do change object layer. And now it's on that layer. Okay, so a couple more things to remember too, especially when you start dealing with the plan down below. And this will be a little bit more apparent once we talk a little bit more about the collage and the areas. But I'll go down here so you can see a little bit closer. Is oftentimes when these surveys come in or line work comes in from some sort of source, GIS or otherwise, the line work is not always perfectly touching each other or matching. And when you start dealing with creating surfaces and splitting them into creating different areas, whether or not the lines are actually joined or touching will make a big difference. So if I select all 4 of these curves here, you'll see that they're not joined together, and I hit join, and you go over to your properties tab, you can actually see that it's a closed curve, and it will tell you, okay, this is a closed curve, which means if I do like a planar surface, or I try to split a surface with it, you know it's going to split it into its own object. It doesn't have to be closed to do that, but closing a curve is the best way to confirm that all the 4 corners are touching each other and they will actually split. But a lot of times, if it's coming from a survey and it's actually like grabbing lines, like they've created lines from the points from the survey that they've pulled, the points don't always match up perfectly once it comes into a CAD software. So it's good when you're dealing with things like curves or edges of pavement or things like that in order to split your areas up, to double check some of that stuff, or just lay out a big surface across the whole area that you're dealing with. So I could just create a surface across this entire area and then hit split, grab all of these objects, and then just see what gets split and what doesn't. And here you can see that it's splitting all these little pieces here. So those are all touching each other appropriately. This one actually ends up being a pretty good survey to work with. Oh, but yeah, you can see it there. So it's a good thing to double check, especially for the areas section, the collage section of this workshop too. Like, this becomes very applicable to that particular part of the workshop and workflow.
Yeah, and it's and that approach of just splitting everything, just it's like sort of like I'm feeling lucky, is actually a great way to work, because then you see, oh, well, all that split fine, great, it's good, and I just need to drill down into this one thing and figure out what the problem is, and so you're not like having to check every single curve to see that it's right, working or not working or whatever. The other thing that you can do is, if there's certain geometries, either A, if there's certain geometries that aren't working right, that exist as a hatch, you can turn those into solid hatches. So if you select the hatch and you go over to the hatch, over to the properties, you can, make it a solid hatch, and then you can explode the hatch and it becomes a surface, which is great. The other thing is, like, if somebody has defined the whole site as hatches, then you can just do, you can just use hatches to generate your whole site. But we often find that it doesn't quite cover everything. But the other thing
very rarely does.
Yeah, very rarely. But the other thing to know about this is that if you do have, all these surfaces kind of they're sitting on the ground plane, Ben's pulling them up just to show them. But if you have them all sitting there on the ground plane, you can use them to trim one another. So if you have you want to fill in a large area and you just want to trim with the other existing areas that you have, you can do that, right? These other surfaces. So it's a great way of defining your plan, and you can manipulate your plan this way as well. You can easily split a surface and rejoin with another. Ben, why don't you just show them the merge coplanar?
Oh yeah, that's a good one. So if I don't need to define this particular lot boundary as well as the setback as 2 different surfaces, I could actually take all of these surfaces within this sort of general lot space, type in join, and you'll still see that it's now being defined as a poly surface. So it's still joined surfaces. and then merge all coplanar surfaces will create a single trim surface for you to use. So it's a good way when you're dealing with lots of different line work to split everything up and then just join and merge the pieces together that you need to be specific.
You don't have to do that for it to work in Topo Kit, but I think it just keeps things cleaner and more efficient. Like the processing of the geometry will be a little bit more efficient. So it's something we like to show people, just to, because I know people like to keep things kind of organized and tidy. We mentioned elevating contours and spots really quickly yesterday, and I think that's worth showing in case you don't, someone isn't working with an existing. I mean, hopefully everyone here knows Rhino enough to elevate contours, right? I mean, but Ben, maybe just cover that real quick.
Yeah. So, if you're dealing with, I'll copy these and just ship these down and do like just get them all at the same plane here so that we can sort of show. But a couple ways that we like to just very quickly elevate contours if they're sort of set at this plane. You obviously have to work from a tag here. That's a little bit trickier, but the ones that do have tags, you can work with a little bit easier. But let's say we're already at 6,000 and we just want to raise this up another 40 feet. The gumball, which is shown down here, you can turn that on if it's not already on. And if you select a contour and just click the blue arrow, you can type in a value that will be related to units in Rhino. So currently we're in feet. So if I type in 40, it will raise that 40 feet. And then I can go to this one and raise it 39 feet and 38 feet. And you can get all of your contours to match up perfectly according to how you need to. Another way that we, more often than not, the way that we do this type of stuff, if we want to be a little bit more exact, is that we'll do the move command and we'll type in V, which sets it to vertical so that your move will only be set to vertical movements. And it's a great way too to snap to other geometry as you're shifting things up. So if you move one contour up and then you want to move all the others at once, you can just move them up all simultaneously to the same plane.
So just by the way, V is actually a shortcut command that we have, Ben, that not everybody has. But the longer version of that is you just type M for move and return, and then V return to get the vertical. It's just like a slight tweak to that is all. Yeah.
Cool. But yeah, that's I think a lot of that's pretty straightforward Rhino stuff too. I think Rhino 7 does have an added piece to the gumball to remember to be careful with that someone ran into yesterday, is the little dot in the middle of the arrow is actually an extrusion command for the gumball. So it's like an automatic extrusion for the gumball. And so just remember, if you're elevating something, be careful not to accidentally hit that button, the little knob there. But yeah, I think that covers most of the input commands for dealing with like a survey coming in, and we'll dive into the meat of the workshop here now. All right, so I am working here out of the, if you've downloaded your package here and you're looking at the file, Chris is going to be going through the play files. I'm going to be using the main files, and I'm going to start with the Topo Kit grading, and I'll move in succession down the line. But I'll always be using the exact same Grasshopper script. The same Grasshopper script will work for all three files. We have it set up well for that. So you're welcome to open it up and follow around wrong and tinker around with it as much as you want, but I'll be going through these like pretty quickly just to give a broad overview of what you'll be doing with the play section. So I think Justin was a part of the intro workshop, but just a really quick overview of how things work here in Topo Kit. We have this geo set that Chris talked about, and what we're doing is we're bringing it in using a layer structure. So we have a layer structure set up in here where we have a parent layer of topo, and beneath that we have an EX for existing, and then we have these different categories that are specific to Topo Kit that will bring in the geometry into your geo set. So currently within my existing geometry set, I'm using all of these contours here, a few spots to define the corners of the mesh, and then a boundary to define where I'm working within. So anything outside of that boundary will not be applied to my workspace. If I didn't have a boundary, everything that's on those layers will be applied. But if I draw this point out here and I put it in the spots layer of existing, it will be excluded. So we basically work down the line, you create a topo, and Chris will show you a bit later how that incorporates with the features. We'll both talk about that. And you can draw the topo right away, and this is showing existing conditions. But we're going to talk a little bit more about how the wonderful mods work. So right now I'm just previewing a slope analysis. So all of this is showing a lighter color as flatter and a darker color as steeper slopes. And if you're in the Grasshopper file and you want to follow along, I'm going to show sort of step-by-step how we're building this, this topography. And I'll show it by plugging these in individually and turning on the layers that are applicable. So right here, the first thing that we have is we have smoothing. This smoothing, essentially what it does is it takes your surface and it takes a defined boundary, which we have defined as this unusual shape here. And you can literally see where it's adding extra points to increase the definition of your mesh to allow you to manipulate it more specifically and intricately. And then outside of that boundary, it's only using the points of those input contours and other geometry in order to build the mesh. So you can tell that inside of our smoothing boundary, we'll probably be able to be a little bit more specific about the way that we're manipulating the topography. We always recommend using the smoothing, which I'll zoom in here and show a little bit closer, using the smoothing prior to using a lot of these other topo mods, because the topo mods really use the points of the mesh in order to manipulate it. So it's a good idea to create a boundary around the areas that you're going to be doing your topo mods before adding in those topo mods and smoothing it. And remember,
we have.
Oh yeah, go ahead. No, go
we
ahead.
have seen some cases where there's dense enough points that like it actually works pretty well. And I was like, wow, I didn't even smooth that, and it looks like the shape that I really wanted it to be. But you can get some strange things happening if you just don't have enough information for it to push and pull, and that's sort of.
These really push and pull the points on the mesh that you have, as well as the features you'll see later are creating points to manipulate the mesh. So there's a lot of different inputs here that will help you define how many points there are for the spacing along the mesh. You can make it really fine, or you can make it very broad. You could actually start with doing very broad strokes and then make it very fine once you figure it out. And then some of these others just sort of help you define the level of detail that you're working with. One thing that we also like to show a lot, because we use these in our workflow all the time, is the geo pipeline. And this is a native component to Grasshopper. You don't need any plugins for it. But the geo pipeline basically allows you to define a layer name in Grasshopper. And these double colons are saying parent versus sublayer versus sublayer. You can define sublayers down to say, I want to use the specific geometry underneath the topo, sublayer of grading, sublayer of smoothing, which is this layer right here, which only has this one object. And then you tell it what kind of geometry you want it to be. So right now we're only asking for curves, and it will live update anything that you add into Rhino straight into Grasshopper. So if I add another curve to this in that smoothing layer, it will update the Grasshopper immediately with that new line work. And you'll see how this becomes super helpful as we are dealing with lots of different types of geometry and using different parameters and inputs for different types of grading and sculpting that we're doing. Okay, so the first thing we do after we do some smoothing, we'll turn off these points so it's a little easier to see, is we add a grading piece of geometry. So I've created this surface here and I've elevated to a specific elevation here on the topography, and that's being input into my grade topo. So if I plug that in, you'll see what Chris was talking about is it finds that piece of geometry, and right now we have it defined as an offset of 3, so it's taking the edge of that surface, it's offsetting 3 feet, and then it's grading away from that at a 25% slope. If I change that slope to 35, it will make the slope steeper and grade away still. I could even change it to 10, and it will grade away to much wider reach. But it really allows you to define exactly what you want to do in terms of the slopes grading away from that. it will read that geometry whether it's planar like it currently is. So it's creating a flat plane at the very top of the of where I placed it, but I could also angle it a little bit and it will regrade it at an angle and create a slope down like that. And then any parameter that I change will also readjust everything accordingly. And then I could also increase the offset too. And so if you see where this surface is located, if I increase this to 10, you'll see that the space away from the surface is becoming flat is also being included in that. But you'll also notice over here that I have a curve input as well. So right now I have both a surface and a curve being used simultaneously with this component. It will take any piece of geometry that you input. I could put in another point somewhere and it will automatically use it inside of this component. And then I can adjust that curve as well and it will update everything to adjust my curve. And so it's a great way to make big broad strokes as you're moving through the grading. The Sculpt component, I'll plug that in and show you that too. This is the one that Chris was talking about, that your geometry is not elevated to the surface. It's flat on the ground. It doesn't have to be. It's just defining in plan view where is the change happening. So you go to the plan view and draw where you want your swale or your mound or something to be. And then you define the parameters that are going to affect the topography. In this case, I'm dropping the height of the topography by 2 feet, and I'm giving it a spread of 10, which means it's only grading 10 feet away from that center line, but it's grading from the offset of 1. So it's offsetting this curve on both sides 1 foot, and then grading 10 feet more down 2 feet. So it's less about defining the slope and more about defining sort of the run and the rise of your manipulation.
Yeah, and when we say grading, we just mean really, this tool is all about pushing and pulling what's there. So if Ben were to have an offset of like 5, that surface that you see in that valley, right at the bottom of the valley, is technically going to be the same as the existing, just pushed down 2 feet, right? So it's really just, it's a push or a pull of the existing terrain at, using these parameters in relation to that input geometry. Whereas the grade is obviously a little bit more, it dictates where it lands and then it goes from there to sort of meet the grade, if that makes sense.
Yeah, so this way, like if I know that the hillside is sloping down already, I don't need to create any artificial down slope. So I can just use the Sculpt tool to just drop the topography down as it exists another 2 feet, or even more if we'd like. We can drop it down 5 feet or raise it 5 feet if we want to. And it will just give me my slopes and this processing this in live to see. So I didn't change the spread at all, but the spread is the, so where the grade goes back up to the existing, if I increase that to say 25, it will show you, it will provide more space for that grading to happen. So now instead of having 10 feet to make the slope, it now has 25 feet to make the slope, so it's a lot less steep. So the Sculpt tool, I like the Sculpt tool. It's a great way to make swales in an existing topography that already has this slope that you need to inside of it. So you'll see that we have this sort of waterfall of mods going down here. And the reason for that is it allows us to define different parameters for the different types of sculpting or grading that we're doing. So we have a second line that we're using here for sculpting. And if I take and I plug my second sculpting component in, you'll see it appear on the site. It does. Yep. Oh, it's because it's fine. But I essentially have a different set of parameters for this one. So instead of dropping 2 feet, I'm dropping 3 feet. I already have a 25 spread on this one and an offset of 5, whereas this one I was working originally with a spread of 10 and an offset of 1. So it's a little bit of a deeper, more prominent swale that I'm creating here, but it's also kind of fun to just play around and see what kind of things you can do with it. If I want to make the height positive and create this big mound going through the site, I could change it to a +10 and create this nice berm coming across the entire site. And then the same with the grading here is we've added another set of parameters of a 35 slope with a 5 offset with a different set of geometry. And that's what you're seeing here is you're seeing this wonderful surface dropping things down. It looks like we're actually, oh, it's because we're creating that path feature, but we'll talk about that a little bit later, probably, right, Chris?
Yeah, I'll actually show the path tool in this next demo of mine. Yeah.
Okay. So does anyone have any questions about sort of how those mods work and how the grading works, or are you ready to get your hands dirty and play with it a little bit? If so, I'll go ahead and stop sharing, and I'll be on the chat for questions too while Chris is showing the play stuff.
All right, so like Ben said, let's get our hands in the dirt here. We've got this is not the right one. This is the one. Okay, so this is a very similar setup that Ben had, and what we're looking at here is the if you're in the package that we sent, you're going to look in the play files folder, and you'll want the grading play Rhino file. And then once you open that, you can just drag the grading play Grasshopper right into it, and it should open Grasshopper up to get you going there. So we have our existing terrain, our existing geo set, as Ben had said. So we have we already have that coming in. In this case we're calling it Topo Base, and that's in a geo set here called Topo Base. We only have a few different inputs. We have our boundary, we have contours, and spots to just pin those corners down. So the Grasshopper file you'll see is a number of different loose components that we're going to start to connect together. So I'm kind of helping you along. There's some training wheels sort of happening here, but we're going to talk about sort of the ways that we can build stuff. So an easy way to get started is something we didn't talk about actually too much that we're just going to start with, which is a patch mod. And a patch mod allows you to take all the stuff that we had taken before to just build a geo set. So we have our topo base, and we have boundaries and all that stuff that builds our sort of base mod, or sorry, base topo. So we would plug this in here, our geo set, to build our topo. But if I want to modify that topo by patching in another change, so here I have a boundary of where I want to change something, and I have a break line. So if I go into 3D, you'll see that this break line exists below the existing terrain. And what we'll do is we'll take the terrain, or the topo object that we created, we plug that in, and then we have our patch geo set coming in from this patch layer, and that's where our boundary for our break line is, and our boundary for our change. So we'll plug that in here, and now we have a patched topo. So if I plug that into Topo Draw, I now have my terrain is all drawn. Just because this is a little hard to hard to see what's going on with these points and stuff, I really like to plug this all into a contour component. So if I wanted to get these components, by the way I can bring them onto the screen is by just double clicking and typing contour. That's one way. So if there's something where you're like, I remember a tool that was about joining curves, and so you just double click and you type join. Oh, join curves, there it is. And now you have a join curve, right? So we really like that way of working. But when you're learning Grasshopper, you may want to, I think it's good to sort of familiarize yourself and go through all these menus as well. So anyways, for now, plug mesh. Make sure you plug mesh into this S input. This is the sort of whatever the shape is you're cutting through. And make sure it's not points. Yesterday we had one person plug points into shape and they couldn't figure out why it wouldn't work. And then we want to give it an interval. I'm going to do 1 foot because that's, for this scale is pretty good. And if we select this, we can see that everything turns green, but it's sort of most of the time it's red and it's hard to see. So I'll plug this into a preview object. And then the default is this bubblegum pink. And we like to use the preview a lot because then we can control what it is. And then this is a swatch. We can just plug the swatch in here. And now we have a white, set of white contours. And then I can hide these other components by simply either just selecting them all and doing Control Q, which previews and unpreviews things. I love Control Q. I use Control Q and Control E all the time. Control E will enable and disable those components. So now what you see is that at the boundary of that patch, it cut. That's where the change is happening, and it interpolates down to the break line. And you'll see that it doesn't necessarily fill in all the way to the break line, and part of that is the way that meshes are drawn. We could manipulate that by drawing a break line from here to here, and then over here we just need to make sure that we refresh that topo set. So what I have is a button at the beginning, and I like to have this refresh button plugged into everything that needs refreshed, and as soon as I plugged it in, it refreshed it. But you can also just hit refresh, and so there you can see it's changing that within that boundary. So I might draw another. The weird thing here is I have nothing to snap to, so I might just need to do that and then move that point over where I want it, etc. Right? So I'm kind of sort of adjusting the terrain to my sort of specifications, and it's kind of even though there are issues with doing drawing that shape, I can see it immediately and I can adjust it by drawing these simple break lines. But maybe I'm showing this to my my design partner and they say, it's a little sharp. We should smooth that out. So I say, okay, well, we can do that, no problem. So we grab the smooth mod and we plug that in. Plug our topo into there, and we say, all right, that's great. And they say, you know what? Actually, this part is really fine for the for being kind of like rigid. Why don't we just like make the bottom part of it smooth? So what I can do is draw a polyline. I just typed PL, but you can type polyline to get a polyline. And I'm just going to have it be in this area here, like kind of at the bottom of my terrain. One thing I'm noticing though is that I'm on the break lines layer. That's not a good place to be because if I hit refresh, everything's going to blow up. So before anything happens, I'm going to change this to a new layer called Smooth Boundary 1. And you can just name it Smooth 1 or whatever, but Smooth Boundary 1. And I always like to give things colors. I'm obsessive about this, but so I'll change this to this boundary layer, change that. And then I need to input that curve somehow. And if you've used Grasshopper, this is probably no big deal, but you just double click, you type curve to get a curve container. And that's all of the containers are these kind of black icons with the hexagonal, shape. And then I'll click on that and right click and say set one curve. And if I have it selected, it will just set it. But if I don't, I'll need to click on it to set that curve. And then I plug that in to the boundaries. And then the last step is to just make sure that I'm drawing this topo and not the other one. So we'll plug this in here. And boom, I have some smoothing happening just in this limited area. There's some things I can do to change that. If I want the smoothing to be more dramatic, there's a few ways to do it. One is to do more iterations or try to make, I mean, strength, it's already at a 1, which is as strong as it gets, really. Another one is to do a remesh, and remesh is kind of crazy, but remesh is actually using the new Rhino sub D modeling. And if I did that, I would say, I would just, it just needs a toggle. So I just say TOGG toggle, a Boolean toggle. And then you plug that in to remesh and you double click. And suddenly you'll see that the points defining the smooth are a little different. They look a little smoother, and you have fewer points. But if I preview the draw topo again, you'll see that they have a crazy pattern to them, and that's like the like quad remeshing that it's doing in that area. So that's pretty fun. So it's taking advantage of some of the latest stuff. And if you're working in Rhino 6, remesh will just, it just won't work. The remesh part of it won't work. But you can change the spacing as well. So instead of 4 feet, I could do 10 feet. And also that changing that spacing is going to change the amount of smoothing as well. And I sometimes I like to layer these in. So I'll have 2 mods. So I might have 2 smooth mods. So I plug this in, use the same boundary, and maybe just change my spacing to 2 feet. Oops. This is going to add a lot of detail, and it'll take longer to draw. You'll see it's going from 1 second to draw it to probably 3 seconds or 4 seconds. But you can see how detailed it is now. That's something you might want to just save, you know, for right before you export, or you might say, hey, like I'm going to redraw these contours anyways, so it doesn't matter, and it looks fine in the rendering. So that's kind of your call.
Also, remeshing does add a lot of processing power to it as well, so that's something to remember too.
It does, yeah, absolutely does. So I can turn that off, and I'm still getting the rough grading, but you know, it's really all about, we think of these tools as design tools, as exploratory tools. And there's still always the step of going into CAD and like just tightening things up, right? And there's that final step. But this can get you to the point of being able to show something, be able to talk about something, be able to see if it actually works. So what else can we do? Let's try out the grade mod, and we'll pull in the grade mod. But what am I going to grade in there? Well, before we use the grade mod, let's draw a path using the variable path component. So I kind of want, I'm just going to create a new layer here called path_CL. And I'll make that like bright purple. And I'll make sure that that's the layer I'm working on as well. So I'll do a polyline and say, all right, well, so I want my path to kind of start, you know, up here and kind of work its way down the slope. And I don't know exactly if this is going to work, but sort of come out somewhere around here. Okay, so that's my path center line that I think will work. So I'll create another curve here in the a curve component in Grasshopper. I'll set the curve there. And then I can make that my center line for my variable paths. So variable paths want some different things. Anytime we try to provide defaults wherever we can. So if you roll over width has a default value of 10 feet. Actually, and if you're working in millimeters, it'll give you a default value, the same actual distance, but in millimeters. Like, or if you're in different, you know, in different units in millimeters, which is great. So you can plug this right into centerline, and there's a default min and max slope, which is 1 to 5%. And then there's a topo mesh input, which is the existing mesh. So the way that we would do this now is we would make another topo draw, and we're gonna draw this guy and use that mesh here. Sorry, that's my lunch. So we have that, and believe it or not, it's actually working already. So if I zoom in, I can see, and I select this, I can see a green line kind of coming through here that is trying to grade a center line for a new path. A good way to see it is to do draw path. And then I can plug that into there and I see what the actual path is going to be, right? Now, the problem I'm having now is that this path is not hitting the bottom. And the reason for that is I've said the max slope can be 5%, but I haven't provided enough length for it to meet that. So I can do one of two things. One, I can make it steeper or I can make it longer. I'm just going to, for now, make it steeper. So if I say 8%, oh, look, now it comes pretty much down to the base. Actually, it looks like it works quite well. So now I have a path that's sort of navigating through this terrain. And I can simply input the path. I can input either the surface or the path, which is kind of nice because you don't necessarily have to draw it. So we can hide this, Control Q. I'll just put this right into the features input, the F there. And then I'll plug my, my terrain that was the step before into here, and I'll draw this terrain. And it's gonna look weird, and I'll explain why. But it's looking weird because our grade topo, our default slope, which you probably should change to something steeper, is 15%. And most of the time we're gonna, if we're grading away from something and trying to, get as little cut and fill as possible, it's probably going to be a lot steeper. So let's say 45 for the slope. And now you can see that that path is navigating through the landscape at that elevation, at that kind of elevation, and regrading around it. So it's a little rough. And so what I may actually do is just so that we're not dealing with as much process, too much processing, I'm going to copy my smooth mod. I don't need this anymore. I'll do a detail of 2, sort of spacing of 2. And then I'll draw a new boundary here on this layer. I could create a new layer called duplicate layer and call this smooth boundary 2. Maybe change the color. And then I'll draw a boundary just around the path because I kind of just want to, oops. I'm snapping to the center point of this curve. And I just want to go around here and just get a slightly more detailed, version around that path. And that's just, I'm only doing that so that I don't have to smooth everything, but you could also just smooth everything. And it's just taking longer to process. It's still going to be way faster than grading it by hand. I can tell you that much. So we're going to do a 2 and then plug that into here, and you'll see, might take a second. Actually, it's probably blowing up because this curve might not be flat. I'm just going to do PCP, which is project to the C plane. And there we go. Yes, that worked. So pretty interesting to see that. I'm not sure what's going on here. This is a little off. This might have to do with my strange break lines that I've drawn. But for the most part, you can see that we're actually just like grading a path in the landscape, and we're figuring out the path. And then we can go back and we can change the max slope to 7 and say, well, does 7 work? And yeah, it kind of works, but it looks like it falls a little short at the end there. So maybe 7.5 will work. And we're kind of maxing it out now. Or you could say, hey, this is a hiking path and we need a lot of variation. So let's just do 12% as the slope max. And then the crazy thing about the variable sloped path tool is you can see that it's different slopes in different areas, right? So it's actually changing elevation, or it's changing slope And it's doing that to sort of minimize the amount of cut fill. So it's trying to optimize between the slope min and max range you've given it, but also between kind of not going any further than that than it needs to. You can also, there's this smoothing mechanism, which allows you to, right now it's at 0.5, you can smooth the path more, and you'll end up getting more consistent grade, or you can smooth it less, like 0.1, and you get more variation in your path, and actually becomes more varied. And there's something strange happening here. I'm not totally certain what's going on there.
It might be your boundary, the purple boundary you have underneath is a little bit tight there.
Yeah, maybe yeah. So the neat thing about all the inputs is it's not like, oh, I've built that and I need to rebuild that now. You're moving an input and then saying refresh. Some of these things we don't have to refresh because they're just directly linked. But yeah, so you get the idea. So that's great. I think we've used pretty much everything except for Sculpt. And let me just show that really quick. We'll plug that in. And for Sculpt, I'm just actually going to remove this path boundary again. I don't know why I did that. I'm just going to keep this boundary so that I have this whole area smoothed out. And this is very odd. I'm not totally sure what's going on here. I think it had to do with some sort of strange interaction there. So if I want, like, say, a feature once we get down into this valley, I'm going to draw a bunch of points. Just rename this Sculpt stuff. And I want like a basic platform. So I'm going to draw a polyline. And I want this platform to be here. And I'll just do PS to do a planar surface. So I have that, but then I want mounds kind of on top of that. So I'll draw points. And I'm going to do like points here, and maybe actually some points kind of at the corners. Might be cool. I've never done this before, you guys. This is like a new thing. So then I'll just select all of these things, and I'll do, rather than having to do a curve or a point, I can actually just put everything in using the geo pipeline as we had before. Geo pipe. There we go. And then we can do sculpt underscore stuff, return. And then I just turn on all the stuff that I want. I just want anything and everything. And then Control Q to hide those and plug it into geometry. And now I can plug that into my draw topo. I save. So now if I'm just gonna go to wireframe view, you can see that I have this kind of platform with these mounds sort of on top of it at the right at the locations that I've specified. The height is default of 3 feet. So each geometry adds 3 more feet. So the flat area was 3 feet, and then I added a point, and that's 3 more feet. So the top of these mounds here are probably about 6 feet. And then the spread, which is the distance that it goes, and then the offset and all of that. So I could say, hey, I actually want it to be a little steeper. So I'm going to make the spread 5 feet. And then it'll be a little bit more focused, and each thing will kind of be a little bit more, but you see that because all the geometries go into the same bucket, it changes everything at once. And in order to have multiple sets of parameters, you would have different components. But the neat thing is you don't have to have multiple components for every single piece of geometry, right? You don't have like you only need it anytime you want to have like really different parameters. And there are ways to make it so that each thing has its own parameter, but we'll leave that for like a much more advanced workshop. The offset, I could then say, well, I actually want sort of more distance around the points. And I could say I want 4 feet instead of 1 foot, which is the default. And that leaves us with a kind of a fun landscape feature that you can see it from above and you can get down below and then kind of walk around this crazy thing. And maybe it's a playground, maybe it's a learning landscape, who knows? I just made it up. But you guys get the idea. So is that making sense, how we can kind of have these mods and we can sort of rearrange them and we can sort of put them in whatever order we want and kind of build on top of things that we've done? We can, draw things in a really rough way, and then we can smooth things out. We can grade through the landscape using variable paths, etc. Okay, well, I'm gonna close up my work here. Is there any other questions relating to this particular piece? All right, cool. So I'll say, or yeah, I'll just close this and stop sharing and let Ben take over.
All right, so I am now in the next step 1. So in the package main files, we're in the number 2 Topo Kit Collage, and again using the exact same Grasshopper file for this setup. And you'll see that it's the exact same topography setup that we had before, with the different mounds and different sculpting happening and grading happening. And I have it previewed in this slope analysis, but I'm going to turn that off really quick and unpreview that. And again, you're welcome to open up these files and follow along and stuff and see what kind of things are happening, and also change things with me if you want to sort of see how things are changing. So this is the section where we were talking about your 2D plan and your areas, and how do you interface between the 2D and 3D areas of your site, and getting those areas in 3-dimensional space without it being too complicated. And we're going to focus mainly on the collage tool for this particular section, because this is the real exciting feature that we use often and love to show people, because we really think this is a great way to approach doing your landscape areas layout for your site. So first thing you'll notice is that we have this collage layer structure here, and all the sublayers are categorized by different materials that we have, and they have different colors to them, and we've organized these different surfaces into the different layers. And we have one that covers the whole site, that's just this lawn green, and then we have all these other colors that are elevated at different places in the site, or in Z space below our site. If I go into the top view and look, you'll see what is sort of a picture of what is going to happen once you start running the collage tool. And you'll see that the red zone, even though it's a larger piece, because this blue zone is above it, you can't see this other section below the blue zone. It's cutting it away. That is really how the collage tool works. So if I don't want that blue zone to be over top of this red zone, I could come in here and raise it up, and then go back to the plan view. Oh, I forgot that I have it turned on. And you'll see in plan view, it's showing this red zone above all of the other the other colors below it. This is exactly how the collage tool works. And if I turn on the preview of this, you'll see that it looks the exact same previewed in plan as it does when I have all those layers turned on in plan. The difference is if I go into my 3D view, you'll see that they're all elevated to the appropriate level and color-coded and trimmed appropriately as well. If I turn off and look at it in 2-dimensional space, you'll see that they're all down here, split together in 2D space as a 2-dimensional layout areas plan for your site. So with this one component, this one tool, you get your 2D and your 3D at the same time. And then with using the project meshes tool from your topography that we've created, you're projecting these two-dimensional areas that are being created up to the three-dimensional place, maintaining color, layer, and they will be converted into meshes with their related colors. So now we have 25 different areas, and these different areas relate to each other based on color and layer. But the fun part is that maybe I actually enjoyed having that blue space be a little bit bigger and not overtaking the red. If I just take that and shift it in the Z space above the red, it will update the plan so that that blue is now covering the red and broke it somehow. But yeah, like in general, that's sort of how it works. And it's nice because, you know, if you're dealing with a site where you know, like everywhere that you're not defining a zone for, you want to be a lawn or a concrete or an asphalt, you can just kind of draw your overall surface below and then just create your pieces within your site that allow you to define your different areas like I've done here. I have this swale is defined, 2 swales, and I have a little concrete pad up here for maybe a house. I have the path running through. And you can manipulate all these by scaling, but you could also do things like do solid points on, and I could take a corner and shift it and make the path different shapes or sizes and manipulate everything at once without having to split and cut things constantly back and forth over and over and over again. So if my boss comes along and says, I don't like that area, that blue area is so big, in fact, just delete the blue area, I can just delete it out, and then it will be totally fine. It will process everything back together, and I can have all of it ready to go in 3-dimensional and 2-dimensional space as well. For some of the other cool things about the collage tool that are good to remember is that once we start talking about features later on, you can actually use features inside of the collage tool as well. So if you create a wall and you don't want that wall to have grass growing through it, or a curb, maybe you don't want grass growing through your curb or something like that, and you bring it into a rendering software and apply materials to it, you can actually cut the curb or the wall or the stairs out of your areas by adding your areas into the collage tool component. So seems like, why would that be helpful now? But when you start working with a lot of back and forth between Rhino and Grasshopper and your rendering softwares, it becomes a very, very handy and useful tool to work with.
So the next one you're going to want to open that's in the play folder is the collage play. So that's number 2 in that folder. And then you can just drag the collage play Grasshopper right into that file, and it will right onto the file, and it should open it up. Not onto the file in the folder, onto the file that's open, just to be clear. So this little Grasshopper window, like one of the things when we're showing Grasshopper, sometimes we like pull one to the side and then have Rhino on the other side. But another way we like to do this is we like to have Grasshopper right here. And if you double click the top bar, it goes away. And it's still there though, but you can double click and make it come back. And it's like, especially if you have things where you're not using Grasshopper a lot, you're setting something up and then you're making all your changes in Rhino and you're sort of seeing all these changes, but every once in a while you need to go in and tweak a parameter or something that allows you to make that go away. So this file has a ton of these like really cool little things that we created, these little shapes, and you can collage with all of these wacky shapes. I've got my shopping cart here, and I'm just shift selecting all the different cool things that I want to do and use. And I just grab these things, one of the good ones. Okay, and then I'm going to just hold Alt and drag with my widget or my gumball, they call it. And I'll start to kind of just pull these together. And so now what? What am I gonna do with these? Well, I want to, let's say I'm trying to create, like a play area, and I've got, I'm going to have these different zones, so I've got you know, this one here, and then this one here. And then I have this one here and this one here. And these kind of fit into an existing site or whatever. And then I'm going to take this and I'm going to scale this down. This is actually going to be like a series of clay mounds that are going to sort of be there. And I'm just collaging, right? I'm just moving these things around. This is going to be a whole series of them as well, maybe, or something else that's like just like maybe the similar shape. But one thing I'm noticing is these are kind of at the same level, and I can't see it. So I'll take some of these shapes and I'll just ZS to zoom in, and I'm doing Control Tab to move between my windows. It's a really handy tool. I'm gonna do a few things here. Number one, I'm gonna start to organize things in space, but I'm also gonna start to think about materials. So I'm gonna put all of these these ones on a layer called, let's just put it on lawn for now. Let's say these are gonna be like lawn mounds. It could be anything, this is sort of the beauty of this. So, and then we'll take these other ones and we'll put these on fines, because we're going to do fines. And so the funny thing is these start to turn red. And part of the reason is because our geo pipeline is reading anything on these area layers. So I'm just going to Control Q and hide this. So I can, again, hide my grasshopper by just double clicking on that top bar. And then I might want to figure out where this goes. Maybe this is like this crazy thing that connects to it. And then I'll take these, and I want these to be like big veg areas. So I'm going to put them on ground cover. And I'm actually going to move all these below. Control Tab. Just kind of move these down below. And then I can take this and I can say, all right, this is going to be a big vegetated area here connecting, near my play area. And it's just going to be this beautiful ecological zone. I'm going to rotate this, scale this up. And, and you can just start to imagine what this thing's going to look like. I mean, you can also draw something and then just draw shapes. It's fine. But when you draw the shapes, don't cut them all out. Just draw the big shape, and then you can always shift it around and change the scale, right? And then we'll take this ecological zone. I'm probably spending too long. I'm having too much fun, you guys. But you guys can sort of do the same sort of thing here if you want, and sort of start to scale up and sort of build your own little area. And the funny thing here is we're doing very little grasshopper, right? This whole demo is going to be very, very little grasshopper. Maybe this is like a connection between the two. And then in between we create a new layer called mulch. And we change the color to brown. Some brown. And then I'm just going to type I or interp curve. And then I'll do my mulch here. This is a lot of mulch, I know. Not the greatest stuff all the time. And then project to C plane so that it's all flat. And then do PS to get my shape. Delete the curve. The neat thing about all these shapes is the curve is there. It's at the boundary of the object, and I'll explain that a little bit more in the next demo. But I'll move this to mulch. And the other thing I can do, I actually want that to be below my veg zones too, because it's like it's always figuring out what's the figure and what's the ground, right? The figure always goes sort of above, and the ground always goes below. So Ben, what was that command that you used to do? It was sync render colors.
Synchronize render colors.
Yeah. So it's funny, Ben told everybody this command that I never knew yesterday. So that you see the brown color for mulch over here. If I hit synchronize render colors, it makes a render color the same color as my layer. And I love to keep it that way because it just means I can see everything as the general color in any given view, right? In any view mode. So now that we have this, and I need to shift this up too, just check everything, make sure all our levels are correct. And, so we're working sort of designing, starting with a collage. And then I will open this up. And this is a really hard one. We just plug this into here. And then we plug this into here. And this into here. And I did it again, Ben. Oh my God, I did it again.
Yeah, you did.
I did like 2 things wrong. Okay, so the weird thing here is the areas coming in, they're surfaces, right? These are we're calling them areas, but they're really actually surfaces. They're Rhino surfaces. But Topo Kit has a thing called areas. So you build an area by putting in the geometry. You keep track of the layer and the color by grabbing that from whatever geometry came in. So the interesting thing here, this is another like little thing about the geo pipeline. This little asterisk means grab anything beyond anything that has areas ... and then whatever's after that doesn't matter. So it grabs all of these layers at once. So any geometry connected is coming in. Well, we can then keep track of which layers things are on by typing details. This is a native Rhino component or Grasshopper component. We plug our objects that we're bringing in here, and then our layer and our color can connect to here. And it creates all these areas that are on, and actually the name of the area is based on the name of the layer there. You can see, so plain area is lawn, plain area is mulch, and we plug these into the collage tool. And if I just hide this geometry, Control Q, and I do a wireframe view, you can also do wireframe up here and wireframe. And I'm also seeing some weird edges, and that's partly to do with the detail settings in Grasshopper. So if I go in here, I actually like to just make all of this 0, 0, 0, and then I change the tolerance to like, we're usually working in feet at Landau, but we go do 0.01, return, and then say okay, and you see that it makes those settings a little better. There's a similar thing in the Rhino settings as well, where you can change how detailed surfaces and things are being drawn. But one thing that's happening is it like all the colors are being blown out, right? That we're previewing. So the way to get around that is by creating a material, and this is like a native Grasshopper thing. And the reason it's getting blown out is because the default preview, the way it creates materials to preview, is they're super shiny. And this command makes it so that they're really not shiny at all. And I like to use that. And now we can see the actual color. The funny thing is we're still seeing the curves from our wireframe view. So it's strange because we're seeing a combo of those things joined. We're also seeing, yeah. So if I were to just turn off these areas, we can now see that whole thing joined together, and it's a plan, right? The next step would be to draw topo, and we don't, we would have a topo that, or we could just grab a mesh from our other, but we don't have it. Let me open up that play files, grading play. I'm going to do a super fast and dirty topo by selecting all of my contours, select objects from this layer, go back over here, Control V. Oops. I'm selecting the wrong thing. I don't think I did Control C. Control C, Control V, there we go. make sure this is in the right place. Then we can do, I'm doing this really fast. We can do a add to geoset. And this lets you directly input things. So I can literally not even create a container and just do a right click and say set multiple curves right into there. And now it's referencing those. And then I just do create topo, or why is it topo? There it is. And then draw topo. And we've got a topo. That's why Ben had those points out there before, but we'll ignore that. And then we put the mesh in here. Oh, we're gonna draw surface. We're gonna draw areas too. And in order to draw areas, it's looking for a mesh. It won't project to anything if you don't have it, but you can project, Control Q, and then we can preview these meshes instead. So projecting the projected meshes and the colors of those meshes. And if we look at it, it's now cutting through. Sorry, it's now set at the elevation of the landscape, right? So, and just like 15 minutes, we created a moderately, moderately realistic plan of a, something in space that's actually has a grade and has different areas and everything. And we sort of designed it too at the same time, right? So if like maybe for a project, you have a bucket of parts and you pull in these different parts and you move them around to do the collage. And then you say, okay, well, this is great, but we need an area plan for the architect or whatever to plug into the CAD drawing. All right, we're going to make hatches. Now this is using the Elefront plugin, but what we'll do is we'll turn these into curves. Or no, sorry, I keep doing that too. We're going to do brep edges. Now a brep is a surface or a poly surface, anything that's surface based. So we plug our surfaces that were coming out of the collage into here. We join the curves, any of the curves that were the naked edges, this EN, those are the naked edges. And then we plug those in and we have hatches. The default is solid hatches. Now, anybody who knows anything about Grasshopper will see this dotted line and say, okay, well, I know that means it's grafted, which means there's different branches of data. So for each shape, it's on a different branch. So whenever I plug my colors in here, I'm going to want, or whenever I preview it, I'm going to want to graft the colors as well. So I'm going to plug colors in and right click and say graft. And that makes it so that each of the colors is on its own branch. That's one way to do it. Or and I can plug that in and now I have these are all hatches that are the right color. They're hatches. And I could, if I wanted to, I could grab this shape and scale it up. Hide this again. And now it's like all my hatches are updated again. Like it's just like, what? Really, really fun, really crazy. So, and we're probably getting way too excited about it. But yeah, we think it's a super helpful thing. And then let's say you had to throw a wall in here and, you could literally just put a wall into this surfaces and it would cut out those other surfaces as well and give you the wall, and a hatch for the wall and all that stuff along with all this other stuff, right? So really cool.
Okay, so right off the bat, you'll see there's a bunch of new stuff added to our example topography and landscape that we're working with before in the previous two examples. You're seeing a couple new things. You're seeing I've added a few areas of paths and concrete lifts, asphalt areas and such. But the real key and the real focus of this is talking about these landscape features that we work with, which are things that have to be built similar to the way that you build topography. So I'm going to show you a little bit of the grasshopper first of where that's happening and what's happening very briefly. And Chris will get a little bit more into the nitty gritty of how things are constructed more intricately once you all start playing around with it. But all of your features are built, like I mentioned before, similar to the way that you build topography. You have a build wall, a create walls, or a create curbs, or a create stairs component. And then after you've created your object or your feature, you can then draw your feature. So it really allows you to put it in, make some adjustments to it, kind of see a rough view of what's happening, and then you can draw it later. That's a little bit more processing heavy. But once you've created your feature, that's really where you take that feature and incorporate it into your overall topographic model that you're building. And I'll show you where that happens too. But we like to use these, again, the geo pipelines of curves and spots in order to feed in. So walls, for instance, are one of the ones that walls and curves work generally the same way, where they take a few different curves and then some spots, and the spots are elevated in 3D and the walls are just down in the 2D space. So if you look here, you can see I'll turn this so it's easy. I have these sets of parallel lines down here that correspond to the location of these walls in 3D space. And then you'll see I have these points up here in 3D space that indicate where the top back of the wall is and the bottom front of the wall is located. And I'll switch from the areas to the slope analysis real quick, just so you can see that a little bit clearer. You can see that the topo is being modified using these spots elevated in three-dimensional space as they relate to their 2D line work down here. These walls don't have to be parallel. They can be different widths at different locations, or they can be 10 feet wide or half a foot wide. You can choose that, and Chris will show you ways using these tolerances in order to control how these get processed together. But the interesting part is, once you learn a little bit about how these tolerances work, we are constructing all of these walls, this wall over here that you see, and all of these walls right here, simultaneously using one create walls component. So all 16 curves are being processed together with all 114 spots. And it's sorting out which points go with which curves based on how they relate to those curves in plan view. So you can see we have these two lines here, and the spots that relate to them are in plan view directly above them in 2D space or in 3D space. So it's a nice way of saying, I don't want to create a different component for each wall, because maybe you have 20 walls on your site. You just have one wall component, and you filter in all of your spots and all of your wall curves at the same time in order to draw all of them simultaneously. Similar to your grading and your sculpting, though, the only reason why you would want to have multiple wall components is if your parameters are changing. So when Chris talks a little bit more about these tolerances, he'll explain that a little bit more intricately as well. So like I mentioned too, the curves work the exact same way that walls work. You have the 2D curves down here that relate to the curves up top. And you have these spot elevations elevated in three-dimensional space in order to indicate where the top back of the wall curve is and the bottom front of the curve. The fun thing that we're doing here is that we're also adding in the modifier for curb cuts. And if I zoom in here, you can see a nice curb cut being created, but it's not using any spots at all. All it's doing is you use a single curve, which right here we're using the curb cut center line being processed in. And everywhere that we have a curb cut center line crossing over top of a curve, it's just generating a curb cut for you automatically in 3D space, and it's regrading that space for you accordingly. And then you have a few parameters that you can adjust of the width of the curb cut, the run of the curb cut, and you can control this flare as well. So it's a fun little handy way of just interjecting into the curves.
And just
Yeah.
just show them, just move the curb or change
Oh
a
yeah.
parameter or something. That it always helps to sort of see it come to life.
Yeah. I'll just shift this curve over here. There's a lot of stuff going on in the script, so it might take a second longer than the other scripts were taking to process them. I should probably turn off the areas. It just shifted my curve cut over. So it's like a nice, you can just draw these lines anywhere along your site and shift them around and add as many curve cut lines as you want to, again, a single component, and it will process them all together for you. Again, the only reason you would need to have multiple, like I have here, is if you have different sets of parameters. Chris didn't see this when I had done this for the example, but I'm actually using curb cuts for these center areas to create a break in the curb to allow water to drain into that grass area. So the parking lot is now draining through those curb cuts into that center zone. So that's kind of like a fun little, you don't have to use the curb cuts just for curbs, like cuts going up for ramps, but you can also use them to do other things as well, which is kind of fun. So that's in general, like how curbs and walls work. I'll talk about stairs in just a minute, but I want to show you where these plug in and start to adjust your topography, because the way to think about things like walls and stairs and curbs in these particular Topo Kit instances is it's really about grading your topography. It's not really about creating a seat wall that's raised above the topography. These are really, think of them as retaining walls, as you're just trying to adjust the grade, not necessarily add chamfers to your walls or things like that yet. There will be mods coming that will do things like that. You can add wall above the grade line of the wall and stuff like that too. But for now, the good way to think about it is I'm just trying to regrade the topography. So I want the back top of my wall to be where the level plane of the topography will be. And then this is that patch topo component that Chris showed you in the grading section. From this place here, I'm plugging in all of my walls and stairs and curbs into the features input of my my patch topo to modify my existing topography using the walls. So all of those features are coming in all at once. The stairs, the walls, the curbs, they break down into break lines and then modify the topography from there. So you don't need to have a different a patch topography in order for each different type of wall or curb or anything. All of these features can be plugged in at the same time into a single component, and it processes them together. So that's the fun part about walls and curves and dealing with just making quick, very precise. It's a good way to make very precise changes. I want this to be at this elevation and change, as whereas the grading tools are really about more push and pull and free form sculpting. And this can be really about fine tuning your site. The stairs component, I'll go back over to that and show you. The stairs component is one of the unique ones that uses surfaces to create. And you take a surface and you elevate it to the elevation of where you want your stairs to be. We typically recommend to create stairs by using curves. So you take a curve and you draw a curve at the elevation of where you want the top of your stairs to be. And you elevate that in 3D space to the elevation of where you want the top of your stairs to be. And then you do the exact same thing through the bottom of your steps. So if I want my bottom of my steps to be out here, and then if I take both of those curves and select them and type in loft, it will create a surface between the two, which you cannot see because I have everything turned on. I'm also previewing states. It will create a surface between those two curves that is actually oriented the way that the stairs component processes the surface. So if I had created this any other way, the stairs might actually go sideways. So we typically recommend use two different curves, and you can do an arced curve. It doesn't have to be a straight curve. I think Chris will show you an example of how to use like an actual like arced curve to create a curved staircase. But again, the way to think about this is it's about for grading. It's about finding those grade break lines for your staircase. So you have a nice preview of what the stairs will look like, and you can actually define the rise of each step. and I believe the default is 0.5 as well. But the run of the steps will be determined by how long the surface is itself. So it'll create stairs for you, and the run of the surface will be based on that. So using a 0.5 rise, it will change all the stairs to match the length of the surface. Again, there may be mods coming down the pipeline that allow you to have a little bit more specifics on how to adjust the stairs to be exactly how you want them to be. But for now, it's really about grading. And so that's a pretty general overview of some of these features. I'll also talk about the path feature as well here really quick, just so you'll get a general idea of what I was doing over here. And Chris will show that a little bit too. So he showed you the variable path tool. Oh, yeah, Chris?
I was just going to say, I maybe stay at a high level here, and then I'll get into the details of the paths, just because it's so straightforward.
Yeah, it's very straightforward. I'm not going to get into the nitty gritties of how you build it, but really it's the variable path tool is about doing as little adjustment to the landscape as possible to get from one point to another, high to low or low to high. The path tool is really about being specific about defining, I want my path to go here, and I want it to be this slope along the entire path. So in this case, I've defined a path center line, and I've given it a slope that will be consistent along the entire length of the path, which is what this surface preview that you're seeing is here. And then Chris will show you a little bit more of how to build that and how that really works. But in general, yeah, those are how the features work. And Chris will show you a little bit more specifics of how to build those and how those come together for you to make really specific changes to your site grading.
Thanks, Ben. That was great. I can't get over it. Like that site, Ben just like built the site as an example for our workshop. It's like, that's not a project we're working on. It's just like, Topo Kit happened. So let me share. And okay, so our last file that we're really looking at is this feature play, and it's number 3, and that should be in the play folder. You can open the Rhino file and then just drag in your grasshopper in order to get that going. You guys may have probably by this time you could do it in your sleep. I'm gonna get crazy and work my way from the bottom to the top, because I think we did say we were gonna do paths, and I think I'll just start down here. So one of the things I mentioned earlier is that these areas are great for a few reasons. One is that you can trim them, join them, merge them. You can untrim a shape. So like if it has a hole in it, you can untrim that hole. They're very flexible, and they have a lot of memory in them. One of the things they remember is the actual curves that they're being split with. And as long as everything's flat, those curves are essentially the line work that you use to split it with. And that's sort of the approach. We're not saying that you should never make surfaces that are 3-dimensional. We're just saying for areas, keep them all flat. And then there's all these things you can do. So one of them is to duplicate the border. So I can, like, as you can see, I have a curve now that's the whole border of that thing. And it's pretty much the curve that was used to create the surface. And so I made that curve. So I'm going to do it again. Dupe. Well, you can also do dupe edge. So dupe E, and it auto completes, and then you hit return. So you select the edges you want to duplicate, and then say return. And then because it's a bunch of separate, I think it might be separate edges. I can't tell. Let me see over here. 6 open curves. So I just say Control J to join those together. And then I can say offset, similar to CAD. And then I can I have a distance offset right now of some number. So I can say, well, I want it to be exactly 2 feet and offset 2 feet. And this is a curve I've already offset. But so that's a nice thing you can do to create, walls, curbs, center lines from existing geometries that are already there. And that's how we created these curves for our center lines for paths. So that's step one. We have these path CLs, and we'll plug that into our paths component here. Again, all of these components are available here to create them under this tab, create curves, create these different, all the main things you would create in the beginning, and then all the draw stuff is here at the end. And then we have our mods for topo and features in the middle, and some analysis and stuff as well. Analysis should probably come last, but actually analysis gets used in the process, which is part of why it's not last, I guess. The one thing we're missing here, it looks like we have a width that's default and a slope that's default, but we don't have the bottom of the curve or a path, sorry. So the way we get that is by drawing a point, and we're going to want to draw that point on the feature spots layer. In our layers, we just put these, I have different blue colors here for this stuff. So I'll go to, even while I'm in the midst of drawing something, I can change layers. And I often do that because I go, oh, I need this to be on that layer. And it saves me a step if I know I'm drawing a bunch of stuff on this layer later. So then I'm on feature spots, and then I just draw a spot there, and then a spot there. And we plug the spots into here. And now we have a path. It's not being drawn yet, so we just plug this over here into path draw. And there we go. We have that. And again, I'm seeing that weird issue with my Grasshopper preview, which I'll change this to 0.01, which is like about 1/10 of an inch. And nice and smooth. Okay, so if I zoom in on this, I can see that my path starts at that bottom location and grades up. It grades at a slope of 5%. I can also do a contour just to show you guys. And I'll do 1/10 of an inch, or 1/10 of a foot, sorry. It's a fair amount of cutting. So a few interesting things happen here. If your center line is based on very simple arcs and line segments, it will grade the corner at the minimum slope, or at the slope that it needs to, so it never exceeds the 5%, right? So it doesn't suddenly, it's not basing it on the center line, it's actually basing it here. And also, just so you know, if I have a center line, just change that to here. And of course it has to recut those contours. If it is a polyline that doesn't have those beautiful fillet curves, it will create a flat landing at the edges, so that you don't end up with really wacky grading at those edges. It's pretty dynamic. We worked pretty hard on getting that to work smoothly. So anyway, so that's how they work. So you're probably wondering, though, maybe if you're paying attention, why does this draw if it doesn't have a point? Well, one thing you'll notice is there's no tolerance here. This just grabs the closest point for the bottom point. So if I were to draw a point here, and I'm going to turn off this piece because this is taking a long time. But if I were to draw another point here at the bottom and move it up, this particular one is going to start at the beginning of that point. And then I can manipulate any piece of this, and it all sort of changes, right? So you can really quickly kind of develop a path this way with a simple center line and a simple starting point in space, one single spot in space. And you know that it's going to be at the slope you need it to be, and you can push and pull it until it matches, or you can change the slope to something weird or whatever. There's a few approaches to it. The one thing you may you may run into if you're doing this is something that looks like this, where you say, oh, but why is it, first of all, not using this point? And second of all, why is it going from this side up? And that's because our curve is flipped from the what our design intention is. So it's not an error. It's just, it's not what we're telling the computer to do isn't right. So all you do there is you select the curve and you type flip, and it will be oriented in the direction you want. So that's an easy thing. If you're orienting your data, it's like garbage in, garbage out. You know, if you're not giving it the right kind of formatted data, it's not going to be working in the way that you need it to be. So those are paths, and I showed you the variable path tool. The variable path tool has the benefit of being able to be dynamic and grade more dynamically within a range of slopes, but it has the disadvantage of you need a mesh as an input there, you know, as a basis for it to sort of adapt to. Okay, so that's paths, and we're kind of looking at pretty much all of the different attributes here of the path tool, I think. Moving up, let's look at stairs. So let's say I have this little, you know, lawn area. I've duplicated my border and then I trimmed it here. And then I have another curve. Do I have two curves? I have two curves. Okay. And then I have another curve as an offset for where I want this sort of amphitheater to land. So I go in and actually an amphitheater would make a lot more sense here. So let's just start from scratch. We're going to select these, make sure we're working on the stair layer, stair surfaces layer. I'm going to dupe border, select this surface, hit return, draw a line, select that line and type T for trim. Or well, T is one of our key commands. You have to actually type trim if you don't have that set up. And then hit click on that curve and it will delete the part you want. With trim, you always have to make sure to hit return when you're done. And then you delete the trim line because I don't need that. And then we'll take the curve and we say offset. And I'm going to say, all right, I know that the stairs are a little bit different. They're not as adaptive, at least not yet. We're hoping to make a version of the stairs that is more adaptive. But we might say, okay, well, this is going to be about 6 steps that are all 3 feet wide. So that's 6 times 3 is 18. Okay. 6 steps that are 8 foot. 6 steps, 3 feet wide. Okay. Yeah. And then they're each going to be 1.5 feet tall because it's going to be an amphitheater. So I'll move this 1.5 feet times 6 is 9. It's a little bit of math in my head. Is that right? Oh, sorry. My brain's shutting down. It's 3 o'clock. It's like without fail. Okay, so I'll take these two. Just as Ben said, you take the top curve and the bottom curve of any given thing. And actually, yeah, so you take the top curve and the bottom curve, but you know, I actually don't want it to be so static. I want to kind of make the stairs sort of change a little bit. So I'm going to take this curve and I'll type rebuild, and I'm going to do a point count of like 4 or 5. It kind of gives you a nice preview there. 5's good. And then that means that I can grab this point and I can pull it out a little bit, you know, change this ever so slightly to make that curve look nice. And then I'll loft between them, as we said before, say, okay, delete the curves, because sometimes I'll put curves like that on some layer, but the curve is there. It's in the stair, right? It's there. And then I take that surface and I plug, it's being brought in via the the geo pipeline. I can plug it in here. And our rise right now is set to 0.5, but because I'm making this crazy amphitheater, it's 1.5. And then I'll plug this into the draw stair and maybe a preview. And I've got my bubblegum stairs here. So that is a great way to manipulate and create an amphitheater that has, 1.5 foot steps. And the neat thing here is if I say, because it's surface, I can actually also do F10 and turn on my surface points, and I could just drag this out here, change that surface, and it's actually I'm manipulating the surface to describe the stairs in a different way. So you can do the straight stairs like Ben showed, or you can also do kind of like curvy stairs pretty easily. Okay, so that was stairs, and Ben actually went through curbs and walls pretty thoroughly, but I'm gonna show just how to do this from scratch. So we have a curb. I've copied 2 edges. You guys could copy some edges too, but I'm just going to start with this. And then, so we have our curves input. And just as a reminder, you're always doing the front curve and the back curve of the wall or the curb, right? So you're describing the front and you're describing the back. And then you're also describing the spots. So we'll plug the spots in, but there aren't any spots that are close enough. And the reason for that, unlike the path tool, the curves have a very specific tolerance for a very specific reason. You're dealing with multiple curves that are, really, what is it called? Proximity sensitive, let's say. So if we look here at the tolerances, so we have a 2-foot tolerance for curves. So that means it's going to pair these 2 curves together as long as their center points are at least 2 feet apart, right? Or are under 2 feet apart. Sorry about that. So if I said, 0.5, it wouldn't pair them. Or if I said, less than 0.5, which is the offset right now, it wouldn't pair them. Similarly, the spot tolerance is only going to connect spots to a curve that are within that tolerance. So now if I draw a point here, if I draw a point like if I'm on the spot layer and I draw a point here, it still doesn't connect it. I don't think. Let's plug this in so that we know whether it's being drawn or not. And it's not. It's not even creating a curb. But if I grab this point and bring it really close, it's still not drawing, partly because it only has a point on one side of the curb. So I draw another point here, and boom, we have a curb. It's a flush curb because we've drawn both of our points at elevation. But if I grab the back point and I move it up, I now have a curb that has some elevation to it. You can see the difference here between the base line there and the height. The other neat thing that we can do is, well, obviously we can manipulate this till the cows come home. We can just push that up and down. But we can also add a curb cut mod, right? So we add a curb cut, and then we can draw a line wherever we want to. Maybe we'll put it here. And then we can reference that line over here and plug that into there. And look, there's our curb cut. And that's just a preview. You can also plug the curb into here. And now it's changing the actual curb. And this acts better on a straight curb. I've noticed some strange things happening on the curve, like the elevations here are a little off. Something I actually noticed recently. So I'm hoping to change, resolve that. We're constantly discovering these things and they get fixed in new versions of the software. But so there's that. And you'll notice with the curb cut, it spits out a curb and a ramp. So if you were doing the grading, you would also include the ramp in your topo. Like you'd have the curb as an input and also the ramp in order to get, you know, this ramp graded. We're thinking about just using a path there instead, but that gives you a sense of how that works. So the other, so very similar to this is the wall. So if I plug my wall curves in here and my spots in here, just like with the curb, nothing happens. So I'm going to put in a point here and here. And now I have a preview of my wall. If I plug the wall into draw walls, I have the actual wall. And then the neat thing with walls, well, curbs will do this as well, but the reason they're separate more than anything is they're going to kind of go in two different directions from here in terms of the kind of mods you can add to them and things like that. But they're essentially the same. So if I add a point over here and a point over here, and what I'm doing is I'm just adding points to the back of the wall. I can zoom in. You can see I have one here that's at the back of the wall. And then I have another one here that's at the back. And another one here that's at the back. And this is the only one that's at the front. So you only need the points that you need, really. And I can take this and I can raise this up. And now my wall kind of interpolates between this spot and this spot for the top. So you always have to think top, back, bottom, front, right? And then, okay, so maybe this doesn't come all the way down and it comes up to, you know, to here, or maybe we say 1.5, and then we, oops, and then we do an alt drag to get the point there. And I'm not snapping it, but because the tolerance is pretty close, it goes to there. And now I have a sort of seat wall condition here before it shoots up to the higher elevation and then comes back down to a curb height, right? Pretty awesome. Then you can plug these things into the topography, right? You can plug the curb, just like Ben was doing. These can be inputs for topographic changes as a reminder, and you can input these into the collage tool as collage, you know, inputs, so that if for whatever reason you had a plan that looked like this, where you had some sort of panel and then you have these shapes and then you have the wall. Just show you really quick. We have the collage areas. We're gonna reference some geometry. Right click and say set multiple geometries. We'll get the details of those. And then we create areas. So we're plugging the surfaces in, and then we're plugging the layer and the color in. I'll create a merge tool. I like to do this instead of like plugging multiple things in at once. It's a little wacky to me. So you plug in the areas and the walls into one. They're now kind of in one bucket. You put that into the collage tool. I'm just gonna turn the preview off for everything. Why is that? Oh, it's the surfaces. And then I can say preview. And I can preview the surfaces and the colors. And what we end up with is it's pretty close. We're getting there. It doesn't look like, every once in a while you get this where something doesn't cut out exactly, but it is producing two separate areas. So if like you know, you needed to just delete one piece. But if let me see if I can just tweak this ever so slightly and it will fix itself. It might also be that, what's up, Ben?
It's because, well, actually, maybe not. Never mind, because the base surface is lower than the wall. I thought it might be because the wall and the base surface there at the same level. But
Yeah, you know, it's strange. The other thing that I find that is happening too sometimes is that whenever you have two surfaces that butt up against each other, like we're doing these paths, if I say join, sometimes it will work. So set multiple geometries. Yeah, there we go. It sometimes gets confused when two things are like connected like that with the collage tool. So it's better to just have them be like just one shape. And so now it works. So the cool thing about this is you could generate all of these as hatches and whatever. So it's just bringing everything full circle. You know, we can bring all of this together, which Ben has done in his example, and it's great. You know, it has this ability to have these three different channels really that you're working on, that the areas, the features, and then the modifications of the topo. And it allows you to just change all these things together, sort of synchronously, sort of asynchronously, and in whatever kind of order you need to. And you're constantly able to see a 3D version of your site, which is, yeah, like just fantastic, because it allows us to design in 3D, you know. All right, now.
Another cool thing I wanted to mention about the walls too to remember is that the bottom front of your wall can also have a varied height. So you could have like varied heights at the back and at the front, bottom, back, top, and front, bottom. So if you're trying to get the wall to meet a specific changing grade at the bottom of the wall, and it's also doing the same at the top, you can add a bunch of points at the bottom of the wall and do the same thing and create those breakpoints for you.
Now it's not going all the way up because it's using the closest one that it has. So I would just have to add another point over here. So it goes like if our grade was going up, you know, it's flat here, going up and then coming back down. It's following that. Pretty complicated wall, right? I dare you to build that in Revit. Okay. Ben, do you want to talk about outputs?
Okay. I'm also just going to go ahead and hit enter and send this to them, Chris. These are the links that Chris was talking about related to. So it's got a link to this campus, which Justin, you may remember from the previous workshop, but it's a link to this Dropbox paper site that we've created that has tutorials, template files for different levels of intensity of working with any land kit work set or like working package, and then descriptions of components and all kinds of stuff, videos and everything to help you sort of learn how things go, primarily with the free components. But we also have links to Rhino and Grasshopper tutorials on that website too that I've included that will kind of be handy to refresh memories if needed. I also just wanted to do a plug for the landkit.design website, which we post news about upcoming workshops, updates, new versions, new components coming out, all kinds of fun things that are happening. So yeah, feel free to explore those all you want. But yeah, outputs. So this is sort of a continuation of the inputs idea, and this is really to give people an idea of some of these cheats and shortcuts that we have found for outputting all this geometry in order to transfer them to different software. The way that we work in our office is we primarily go from a Rhino and Topo Kit setup into Lumion, and the workflow for that is very similar for like Inkscape or a lot of these sort of like separate rendering software. But one thing to make note of, and this applies for the setup for installing a new plugin, and I'm going to be talking about this plugin Elephant, which is one that we use quite often. If you have Rhino 7, it's available in the package manager as well. But if you don't have Rhino 7, you can go through the traditional Food for Rhino website to go get Elefront and download it and install it the way that Chris mentioned that you install LandKit. But Elefront is really a sort of a Grasshopper user's Grasshopper set of components for interfacing and using things like blocks and annotation and dealing with baking your geometry from Grasshopper into Rhino. So if I have this, I'm going to show you this area plan that we worked on quite a bit, where we brought in all these houses just as examples for this project. And this is all processing in Topo Kit right now. It's using the existing contours, and then we've created that boundary for a proposed contour. And we have all these areas. And this is showcasing, I'll go ahead and fix this really quick. So all the color schemes are fixed. And what you're seeing here is you're seeing an added extra element. So you have this custom preview and the create materials for previewing this output of our different areas here that are down here on the C plane. And the outputs now are being processed through some of these components, a couple of components that are available through Elefront. One of them is called define attributes, and one of them is bake objects. And you'll see that the input for bake objects, so if you want to bake something, you can, for most components, you can right click them and click bake. And then you can actually select a layer to bake them into. So I could click features and hit bake, and you'll see that all of that geometry comes into Rhino. Turn it off. And you'll see that's coming into Rhino. And if I go into like a rendered view, you'll see that they're all the same color. Well, that I still have this previewed. Or they actually all have the colors. I think I kept the materials on there somehow. But typically it doesn't categorize them well. It doesn't put them on specific layers. You'll see that they're all on that layer that I have them on features. So they're not all on their own individual layers or anything like that. But with these Elefront components, you can actually say, okay, well, I want that color that's coming out to be a material, and I want that material to be input into this thing called an Elefront attribute. And then I also want to take the layer that it's on, and you'll see all of these layers are defined as where they're coming from. So they're under the the parent layer of areas underscore areas, and they're named based on their layer, sublayer that they're in, which is all of these here. And what we've done is we've taken this native Grasshopper component called replace text, and we're saying find all of the instances of underscore area and replace it with an instance of underscore materials. And what you see coming out of that is a new naming structure where it's all listed as materials. And then that layer structure is being plugged into the layer input of the Elefront attributes. And all that information is being categorized as just a general Elefront attribute, and that is being fed into the attributes input of the bake component. So we have all of our meshes coming in from our project areas. All of these are coming in, and then all of our Elefront attributes, which are directly related to each mesh, are coming in. And then we're defining a name for the bake. So we're saying we want this bake name to generally be called whatever, current areas 3 is what we're calling it. And then we have a toggle that allows us to click this button and bake all that geometry straight into the materials layer. So now all of our materials are in here. And do this. And then go into the rendered mode. We'll actually have all their colors, but more importantly, they're actually under their appropriate layers. So if I go to the asphalt and do select objects, it will select all of my asphalt pieces. In addition, it will have embedded inside of the asphalt features on that layer, the material that we've created for it and the color we've created for it. And the reason that that's important is because a lot of these sort of third-party rendering softwares that you would export things into, like Lumion or Inkscape, will read the material of the object, not the display color. And then that's how you apply materials across multiple different objects at once. Yeah, Chris?
Yeah, so there's a few, like there's always a few different ways to skin a cat. And another way to think about this is, and I, in the past, have thought about this, is that all my area, I usually have like a template file where I have areas that have materials and colors defined. And then I have a, a set of material layers that have materials defined as well. So in those cases, you can skip the whole material assignment thing and you can just bake it onto the layer, and it will just use whatever the material layer is. So that's another way to define the layer, but or the material, and that's a preference thing. But the other thing to pay attention to is the if you go over, you don't have to like do the whole thing, but if you go over to, the bake name, exactly. The way the bake name works, and there's a few things you just have to be careful with here, is that it tags these things with this name, right? And so if you use that name in multiple places and you go to bake multiple things, like multiple bake components, that is, it will overwrite them. Like it'll bake this one and then it'll bake this one and it'll overwrite it. But that's part of the beauty. We want it to overwrite things, but you just have to make sure that for any given bake group that you're doing, that it's called something else. So in this case, we've called this current areas 2 or whatever, but then you may be baking some plants over when you're using Plant Kit, and you just want to make sure that those are called current plants or something. And then the neat thing about that is when you go to update your iteration of the design and you say, okay, well, this is a new file, or I've saved the old file and I just want to replace what's there. I don't need 6 versions of the design in one file, or even 2. So I'm just going to overwrite that, and that's what the bake name does. It overwrites the geometry. And Ben has just put it on a whole new layer called project areas, but it also would have deleted everything within the materials layer as well.
So now there's no longer, except for some features that I had baked earlier.
Yeah.
None of these, there's only one mesh here. There's no longer 2 meshes because it deleted my meshes in the materials layer and replaced it with a mesh in this new layer structure that I've created, only because they have the same bake name.
Yeah. So that bake name, just pay close attention. It's like nitroglycerin. It can really, move a lot of stuff at once, but it's also, you can blow some stuff up as well. So.
And like Chris had mentioned before, or like, I mentioned that Elephant has a lot of unique features to it that are handy. That's also where you can do a lot of stuff with hatches through Grasshopper. So whether you're bringing hatches into Grasshopper to manipulate them, or you want to define something as a hatch to export it into Rhino as a hatch, these are really the set of tools that we use often to do things like that. If we get a survey and we have a bunch of hatches that we want to manipulate directly in Grasshopper, this extended geometry parameter component will actually allow you to input hatches in here or input blocks into here. The native Rhino or Grasshopper components don't really work that way with blocks and hatches as well. Any other, one thing that we didn't actually mention in the inputs section of this is when you're dealing with stuff in Grasshopper, and specifically because of tolerances and distances and rounding, you want to make sure that a lot of your geometry that you're working with is close to the origin. And when we say origin, if you're not familiar with Rhino, we're talking about the sort of starting place, the 0, 0, 0 point in Rhino, where when you open up a brand new Rhino file, you're at this grid with the XY axis showing. That's the origin point of Rhino, and things that are close to the origin don't have to do as much rounding. So if someone takes a survey and it's related to that origin in space, it's good to remember to bring that survey and that geometry, either copy it and bring it closer to the origin, or just move it closer to the origin so that Grasshopper doesn't start breaking, which we've run into a few times when you're trying to process things.
Yeah, Rhino will have trouble previewing things, and sometimes like just stuff will break with some of the things that we're doing in Grasshopper.
Yeah, and that's
So
not, yeah, that's not specific to like Topo Kit or anything. That's just really anything that you're working with in Grasshopper,
yeah,
having it
exactly.
closer to the origin.
It's just, that's a good practice in any 3D modeling software, to be honest. Rhino, Revit, SketchUp, whatever. It's just keep it closer to the origin. We're always, the one thing we do stick with is the elevation of something, though. Like if like all these contours are at whatever 1,000 feet, these are at elevation, like we keep them at elevation. Part of the reason is because whenever you go to export stuff, it's really great if something comes into CAD as something that's at elevation. So if somebody goes to label it, it's actually correct and the right and at the right location. And that's Ben's actually going to pick up from there and talking about exporting contours.
Yeah. So contours, again, you can set up the same workflow for contours that you have for any type of geometry using the Elefront workflow. So I could actually, pull these pieces over here, and I just did. Once you start dragging something in Grasshopper, if you click Alt, it will copy it. So that's like a nice little hotkey for you all. A little easy way to copy things around. But if I take this and I change this bake name to current contours, and I make my bake location or my bake layer name as proposed contours, and you can see that I created that in my Rhino file already, but if I hadn't, it would create it for me. And if I take my contours and I just plug them straight into my geometry input there and I hit bake, I now have all of my contours in here. And these contours can be grabbed from that layer, select objects, and I could then export those to a DWG and then bring those directly into, and this is a great way to see like the range of different exports that you have for Rhino and other software. If you've dealt with Rhino a lot, you're probably familiar with some of these, but I don't think I've run into too many, except for maybe like exporting to I can't remember the name of it anymore. There's a few big softwares that you can't export to, but there are definitely a range of different exports that will work across every software. So we haven't ever run into a major snag for exporting, but it has the DWG drawing for AutoCAD, and you could export these to an AutoCAD file and bring them into save, and then you can choose 2007 natural polylines, and then all those will come into AutoCAD as polylines that could be easily changed and manipulated as polylines in AutoCAD software. So when he was talking about your exports become contours, you've made all these changes, you haven't adjusted your contours to sculpt your site, and then at the end you have all these contours, you export them out, and now the engineer or whoever's sculpting your site can now use those contours for grading. Do you want to say something, Chris?
Yeah, I mean, well, and contours aren't always the right thing to send to somebody. Like if you're dealing with a civil engineer, they might want points or a mesh. And you can also do that. You can export the points out as like a group, or you can literally just bake the mesh that's coming out of your topo before you start cutting contours. Yeah, so I think civil engineers, Civil 3D can take points, and you can export those as a .txt file, and it's like basically all the coordinates of all of the points. You can also export a mesh, which will work in many places. The other thing worth mentioning that we didn't mention yesterday was that there's a new plugin for Revit called Rhino Inside, and it literally will run Rhino inside of Revit, and you can open up Grasshopper, and you can do Topo Kit and Plant Kit and things like that inside of Revit. And we've actually worked through some workflows where you can spit out site objects as, it's spit out our area objects as we usually have them, the projected area objects as site, like native site objects that are actually also colored to the right color in Revit, which is was a pretty satisfying thing when we achieved that. We also have the ability to do that with plants as well, but and have all the data in the plants. But yeah, that's something that if anybody is interested in learning more about, or if there's anything you're interested in learning more about, we are not just software developers and trainers. We do custom scripts, we do custom solutions. Um, and so anything related to this stuff, let us know. There's actually some firms we've started actually doing this work for as a precursor to them learning how to do the work. So there's a number of ways of approaching this sort of, and kind of getting this into your particular workflow. Right. So if we're going to SketchUp, SketchUp is an interesting creature because if you spit everything out at the same time from Rhino, everything is just sort of at the same level in SketchUp. So if you have areas connecting to one another, they're suddenly now in SketchUp, because of the way it works, they're sort of stuck together, right? So it actually is really one of the hacks that we've figured out is that if you take all the geometry from each layer, just take all the lawn and then turn that into a block in Rhino. And usually we just start a new file. But if you turn all of that into a block and then you just go through the different material layers and turn them into blocks, and then you can spit out all the blocks and send them over, export them all at once to SketchUp. They're nicely organized then in SketchUp as components, which is what SketchUp calls it. But we also have we created a script, and we'll probably be doing creating more scripts for documentation that are relating to hatches and blocks and things like that make these things easier to go from this software to somewhere else. And that's something else to watch for in the development of LandKit.